So, today we're going to be talking about motion graphs. And motion graphs are graphs that describe either the distance an object is going in a certain amount of time or the velocity at which the object is going over a certain amount of time. So, the first one we're going to talk about is speed. And what we're seeing here on this slide are three different examples of an object displaying a speed or a displacement over time. So, graphs are definitely easy to understand. They're better than trying to describe the motion of an object in words. So, some topic review words that will help you to review are motion, which is the change in position over time. Um, and speed, which tells us the rate at which an object moves. Recall that velocity tells you the speed in a given direction of a moving object. And then we're going to get into acceleration on this video as well. And acceleration is the change in velocity over time, or it tells us the rate at which speed or direction changes. Because remember, acceleration can occur when an object speeds up, slows down, or turns. So first we're going to look at distance time graphs. And plotting a distance against time can tell you a lot about the motion of an object. So time is always plotted on the x-axis. And so the further to the right on the x-axis, that means the longer the time from the start. And distance will be on your y-axis, which is your vertical axis. And of course, the higher up the graph, the further from the start. Now, if an object is not moving, you will see a horizontal line on a distance time graph, because as time continues on, that distance that that object has moved remains the same from point of origin. So we say that that object would be at rest in this case. If the object is moving at a constant speed, you will see a diagonal straight line, which means it has the same increase in distance in any given amount of time. Most things do not move at a constant speed. Most things accelerate. Okay, so in this case here, you have two different scenarios. The dotted red line represents an object moving at a certain constant speed, and the blue line represents an object also moving at a constant speed. You can see that the steeper the line, the faster the speed, okay? Because as the object moves away from point of origin, it's not taking as much time to get to those points. For example, if you look at this point here, where I'm pointing, compared to the line here, they've reached the same distance, but the blue object took longer to get to that same distance. So constant speed on a distance time graph is always shown by a straight line on the graph. All right. So graphs can also show acceleration. So in this case here, in this scenario, the line in this graph is curving upwards. And so that means the object is increasing in speed because the line is getting steeper and steeper. So as the object moves from point of origin, the distance the object is moving is, as time goes by, is getting more and more. So that means the object is increasing in speed. Now, we could also look at this, um, if we could extrapolate a line that went from where I'm pointing here and going like this, which curves the opposite direction, that would indicate that the object is decelerating or decreasing in speed because as time goes by, the slope of the line starts to decrease. So, in summary, let's look at a graph that has several different examples of, well, it's one object um, moving through time. So remember that distance is going to increase when you have a positive diagonal line. So in this case, this flat or straight diagonal line represents an object traveling at a steady, constant speed. And then it levels off here for 2 seconds and is at rest. And then it starts to increase in speed again until it gets to 6 meters, and then it takes another rest for 1 second. And then it travels back to point of origin at a constant speed. So it's returning to point of origin at a constant speed. So an example, this could be, let's say, a person walking um, for 2 seconds at a constant speed, stops for 2 seconds, then starts to increase its speed again, and then at 6 meters, that's the farthest it's traveling, it's gonna take that person is taking a break for a second, and then it's going to walk back to point of origin, for the remaining seconds there. It's going from 6 meters back to point of origin at a constant speed. So a sloping downward line like this means the object is returning to point of origin. All right. So our next thing we want to talk about are speed time graphs or velocity time graphs. Um, so velocity over time, or the change of velocity over time, is what we call acceleration. So remember, recall what velocity is. Velocity is an object traveling at a certain speed in a given direction. So it's basically speed in a given direction over time. So you'll always see your time on the x-axis and your velocity will be on your y-axis. And that could be meters per second, it could be meters per hour, it could be kilometers per hour. Same thing with time. Time could be in hours, minutes. In this scenario, we're going to use, just for purposes of this example, meters per second velocity and for time, seconds. So speed time graphs look, or velocity time graphs look much like your distance time graphs. So you got to make sure you look at your labels here. Um, so in a straight horizontal line on a speed time graph, that means that the velocity of that object is constant. So a straight line that's horizontal does not indicate that an object is not moving. It's actually is indeed moving, and it's moving at a constant velocity. So um, in the case of this one here, where you have a red dotted line that's diagonal and a blue diagonal straight line, this object that's red, that indicates on the red line, is increasing at a constant acceleration. It's increasing at a faster acceleration than the object that represents the blue line. So this graph shows constant acceleration. The object is moving at an accelerated pace, and it's a constant accelerated pace. In the next scenario here, this graph is showing decrease in speed. It's decreasing constantly, okay, as time goes by. So the object that's represented with the red dotted line is decreasing much more quickly, okay, than the object that's represented by the blue line. And then, of course, this one here, you can see the blue line is right on time, on velocity of 0 meters per second. So in this case, that represents an object at rest. So to summarize, in a velocity time graph, it shows us how the velocity of a moving object is going to change with time. So the steeper the graph, the greater the acceleration or deceleration. A horizontal line means the object is moving at a constant speed, and a downward sloping line means the object is slowing down at a constant rate.